Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives for exponential functions. So we have to differentiate each of these four exponential functions. So let's start with the first one. Now the first function f at x has this exponential term in the numerator and this linear function in the denominator. Now we have to find the derivative of this function, and it will be easy to do that if we can move this x term to the numerator, and that will make its exponent negative. So we can rewrite this function as f at x equals e exponent negative x cubed times x exponent negative 1. Now we can find the derivative of this function using the product rule, because this function is made up of two functions. So the first one is this exponential function and multiplied to this x term with the exponent negative 1. So prime of f at x. So as per the product rule, we'll find the derivative of the first term. So for this exponential term with base e, the derivative will be the exponential term e as it is times the derivative of its exponent. The exponent is negative x cubed. So as per the power rule, the derivative will be negative 3x squared times the second term plus the first term, which is the e term, times the derivative of the second term, and for that we can use the power rule. So we'll move the negative 1 from the exponent to the front and subtract 1 from the exponent negative 1. Now we can simplify this expression. So in the first part, we can multiply negative 3x squared by e negative x cubed. So we get negative 3x squared times e exponent negative x cubed, and then x exponent negative 1 can be changed to 1 over x. So we make the exponent positive. And then in the next part, so minus 1 times x exponent minus 1 becomes negative x exponent negative 2, and then e exponent negative x cubed. Now we can simplify the first part. Prime of f at x. Now we can multiply negative 3x squared by 1 over x. So one of the x's will get cancelled out. So we are left with just negative 3x e exponent negative x cubed. And in the second part, we can move the x square and e exponent negative x cubed to the denominator, and that will make the exponent positive. Now in the first term, we can move the e term to the denominator to make its exponent positive. So we get negative 3x over e exponent x cubed minus 1 over x squared e exponent x cubed. So this can be the final answer for the derivative of the first function. Now we can also factor out e exponent x cubed from both fractions, but you can also leave it like this, it should be fine. But if you want to factor out the e exponent x cubed from both terms, then the final answer will be, so 1 over e exponent x cubed, and then in parentheses it will be negative 3x minus 1 over x. So this can be the final answer for the derivative of the first function. Now we can analyze the second function. The second function is f of x equals square root of x times e to the power x. Now the first thing we should do is change the square root on x to a rational function. So we get f of x equals x exponent half times e exponent x. Now we can use product rule to find the derivative, because this function is made up of two functions, x to the power half and e to the power x. So prime of f of x equals, so the derivative of the first function, x exponent half, so we can use the power rule. So as per the power rule, we move the exponent to the front and subtract 1 from half, times e exponent x, the second term, plus the first term, x exponent half, times the derivative of the second term. So the derivative of e to the power x will just be e to the power x. Now we can simplify this expression. So prime of f of x equals half times x exponent. So half minus 1 is negative half, times e to the power x plus x to the power half times e to the power x. Now in the first term we can move the x to the denominator to make the exponent positive. So prime of f of x, so 1 over 2 times e to the power x will just be e to the power x over 2. So we'll get e to the power x over 2 and then x exponent positive, and then plus x exponent half e to the power x. Now in the given function, the exponent half is given in the form of a square root. So in the next step, we can factor out e to the power x from both terms, and we can change the exponent half to square root. So this can be the final answer for the derivative of the second function. Now we can analyze the third function. So the third function is h at t equals et squared plus 3 times e exponent negative t. Now e here is the Euler's number, it's a constant. Now in the first term, e is being multiplied by t squared, so e is the coefficient of this term. And since e is a constant, so when we find the derivative of the first term, e stays as it is. So we get prime of h at t equals e times the derivative of t squared, which is equal to 2t, and then plus 3 is the coefficient of the second term, so it will stay as it is, and the derivative of e exponent negative t will be the e term as it is given, times the derivative of the exponent, and the derivative of negative t is negative 1. Now we can simplify this expression. So we get 2 et and then minus 3e exponent negative t. Now we can make the exponent on e positive by moving it to the denominator. So prime of h at t equals 2et minus 3 over e exponent t. So this can be the final answer for the derivative of the third function h at t. Now we can find the derivative of the last function g at t. Now in this case, the exponential term is in the numerator and the denominator. So here we can use the quotient rule to find the derivative of this function. So as per the quotient rule, prime of g at t equals the derivative of the numerator. So the derivative will be the e term as it is given times the derivative of the exponent. So the derivative of 2t is just 2 times the denominator plus e exponential t and minus the numerator, which is e exponent 2t times the derivative of the denominator. Now the derivative of 1 is 0 plus, and the derivative of e to the power 2t is the e term as it is given times the derivative of the exponent 2t, which is just 2 over the square of the denominator. Now we can simplify the numerator. So in the numerator, so 2 times e to the power 2t will just be 2 e to the power 2t times 1 plus e to the power 2t. And in the second part, so in the parentheses 0 goes away, so we have just minus e to the power 2t times 2 e to the power 2t over 1 plus e to the power 2t squared. Now we can distribute 2 e to the power 2t into the parentheses. So we can multiply both terms by 2 times e to the power 2t. So we get prime of g equals, so in the numerator we just get 2 times e to the power 2t, and then 2 times e to the power 2t times e to the power 2t will be equal to plus 2 e to the power 4t. So we add the exponents because the bases are the same, and then minus 2 e to the power 4t, because e to the power 2t times e to the power 2t will be e to the power 4t over 1 plus e to the power 2t squared. Now we can combine like terms in the numerator. So 2 e to the power 4t and minus 2 e to the power 4t get cancelled out. So we are left with prime of g at t equals 2 e to the power 2t over 1 plus e to the power 2t squared. So this should be the final answer for the derivative of the fourth function g at t. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.